Hello everyone and welcome to the C# 101 class and introduction. This is week number, week number 5?
Yes.
Yes, next week is the final week of the class. Awesomeness. All right, so tonight we've got several different things that we're going to be covering, and we decided to toss in a few extra things for you guys since you guys have all been doing such an awesome job in this class to make things a little more interesting. Tonight we're going to be looking at the following. We're going to kick things off with exception handling. From there, we're going to introduce you to String.Format so that we can finally get away from concatenation and start using formatters, which will make life a lot easier for not only us, but you guys as well. From there, another thing that we're going to be tossing out completely new that was not in the original syllabus, file I/O, input and output. How do we save stuff to our hard drive, and how do we pull that stuff back in? From there, we're going to be taking a look at enumerations, and then finally, we're going to wrap the night up with a look at basic debugging. So this may have the class going by a little bit longer than usual. We'll see. The day class ended up taking about an hour longer. For those of you over in BuzzNet right now, welcome. And for those of you that are concerned because this is week 5 and it's just about to be over, fear not. We'll give you guys about a week breather. And then we're going to come back with the 102. So, let's keep this party going. I say we keep the C# courses going until you guys are all professionals. I'm pretty sure we can do 101, 102, 103, 104, 105, 201, trust me. We've done well over 200 hours with Private 101 with just one student alone. I'm sure we could keep you guys locked up for a long time. So, yeah. With that, let me go ahead and hand it over to Nelson. And Nelson, let's get things kicked off with exception handling.
Okay, so I'm going to go ahead and open up a new project. Open up a new project, I'm going to go ahead and do something. Okay, so what's going to happen to this program, everyone? Any guesses?
Good, we're getting acceptable answers. Everyone should say that. Ooh, Tim is being more specific. I like it.
Alrighty, so when I run this, we'll get something called an exception. We will notice that the execution of the program is halted, and execution actually physically cannot resume because an exception has been thrown, and that's it.
Your program just crashed, basically.
Yeah, it crashed. If I was running this watch this. If I was running this outside of Visual Studio, of course, the student
have to go there the long way, Nelly.
No. Okay, so if I was going to go ahead and just run this program, we'll get this error, but then we'll see this very familiar application has stopped working message that you might have seen a variety of programs, particularly UDK, showing this message from time to time saying that your program has crashed. Well, what happens in C#, when an error happens in C#, when a runtime error happens in C#, what happens is what's called an exception gets thrown. An exception is the word for a runtime error. What I mean about a runtime error is there are two primary forms of errors within any programming language. You'll have compile errors and runtime errors. So if I were to, for example, delete the semi and try to build, we'll get a compiler error. There's no way for this program to even compile. But those aren't the kinds of errors that we're going to be talking about here. Those aren't the kind of errors that you could even catch. You have to fix your syntax in order for your application to compile. We're going to be talking about runtime errors, which, again, are called exceptions. So when a piece of code in .NET decides that there is a condition, some sort of a condition, that makes it so that that method that you are invoking can no longer execute properly, it's going to throw an exception, meaning it's going to cause a runtime error. When I say throw, which I will be using from here on out, what I mean is it's going to raise or cause a runtime exception to happen. And exceptions, again, are just runtime errors. So what we're going to be talking about, at least in this section, are ways that we can write code that could potentially throw an exception, but we can provide our own handler logic given a particular circumstance that it would be designed to correct the mistake. I'll also be talking a little bit about exception design, at least as far as what kinds of exceptions there are, what kinds you should catch, what kinds you should not catch, and so on. Now you'll notice I use the word catch. That's actually going to be a very important part of the terminology of exception handling. To actually write code that will make this error not happen, what we have to do is we have to wrap it in a special block. And that block is called the try block. The try block is a block that is only valid within a method. And what it's going to do is everything inside of the try block. So again, that's the keyword try followed by a code block. And a code block, remember, is just a collection of C# expressions or statements. And everything inside of this try block is encapsulated in what we can, it's encapsulated in such a way that we can cause or write our own code against our program and create horrible, horrible sentences. I think I just had a runtime exception myself.
I think you did. You may have even blue screened.
Our try block defines a section within our code that we can recover from exceptions with.
There you go.
But that's not the only part of this that we need, because if you see right now, we have a compiler error. It says expected catch or finally. Try block is only valid if immediately preceding it, you have a catch block or a finally block. We'll be talking about finally here in this section, but first we're going to talk about the catch block. This is the simplest catch block. This isn't the only kind of catch block that you can use, and in fact, the use of this particular catch block is highly discouraged, but because it's the simplest catch block, I'm going to use it for the example right now. So I'm going to go ahead and write some code. Before I even explain it, I'm just going to ask everybody, what's the output of this program? Just for people to guess what might possibly happen. Okay, we got some in catches, we got a nothing, and we got a both. If I were to run this program, of course, I'm going to go ahead and add a console.read key down here. Let's go ahead and run it and see what happens. We get in catch. And here's why. The try block, everything in this try block is protected, or not protected, but it's going to collect any exception that does happen. But this is the very, very important thing about how runtime errors or exceptions in C# and indeed any language that supports exceptions work. The exception will terminate executing the try block completely and immediately start execution on the first catch block that is appropriate for the kind of execution or exception that was thrown. Now, this catch block is a special catch block syntax which will catch every runtime exception that's thrown. So what happens here is that int.parse, we invoke that method correctly, but then it decides, wait a sec, user gave me some really dumb input, and there's no way I can do anything with this. The state of the program is invalid. I'm just going to go ahead and throw up my arms and say, you know, I can't deal with this anymore. And so it throws an exception. And that exception then bubbles up here to line 14. But what it does is it stops execution in this try block. Execution will not continue in this try block any longer because it can't. The sort of philosophy of an exception is that something happened exceptionally, meaning something happened that should not have happened, and as a result, the state of the program might be incorrect. Therefore, any lines of code that immediately follow a method invocation that raise an exception are no longer considered to be valid, at least philosophically. That's how you should think about it. The console.write line should not be considered valid if the int.parse method was unsuccessful in doing its job. Now, because we have this special catch block right here, which again is a special syntax of the catch block that will catch any possible exception thrown, we can recover from any error that happens inside this try block and provide our own logic to occur immediately after the exception was thrown. So again, inside of int.parse, actually, well, if I had the debugger, I could show it to you guys, but inside of the int.parse, we start here, exception gets thrown, bubbles up all the way into main, notices that there's a try block here, says, okay, we're going to stop execution of the try block, and we're going to immediately bail out to the first catch that's applicable for the current exception.
So let's go ahead and reset. Let's start testing out the ready check stuff. Let's go ahead and reset and have everybody type this out real quick. I want people to get their hands dirty tonight with this.
All right, so if everybody participating who's going to be participating?
Come on, guys. Click that participate button. It's not like anything difficult you've got to type.
It's not going to bite you or blow up your, well, it might blow up your computer.
Yay.
It's my code.
Stop being so negative, Nelson.
All right, so I'm going to hit the button, and what do we have? Ooh, nice.
Tim's already done.
What?
What? It's not like a lot of code that they had to type out.
But only catches within braces, right? I'm not sure what you mean by that question.
It's only going to catch within the tries block, within the tries braces, correct?
Right. If I were to move this int.parse outside of the try block, that would still throw an exception. That was not handled.
That's right.
We didn't talk about throwing exceptions, didn't we, Jason?
Why does it seem like you actually did use a throw once?
Did I?
I thought you did.
I don't think.
Okay.
What class were you in?
Lyric said, nope. We've done... come on. I've been involved in thousands upon thousands of hours of training videos. We've definitely used throws before, but I don't know. Okay, so Sag said that you said throw, but you didn't use it. Well,
Okay.
give him a treat. Throw a darn exception.
All right. Well, I want to kind of say that until the end of this discussion.
Finale. Okay.
But yes, the grand finale.
A couple reds left. Remember, go ahead and click on the ready.
1 minute.
Or 1 minute if you're still working on it. Test that out too. All right. Thanks, Ryan.
Yeah, I'll be giving a quick some scenarios about why you would do exception handling very shortly here.
Yeah. Did Ken just say he's never needed to use this because he always writes perfect code?
Huh?
Never. It's all been perfect code. It was just funny.
But see, here's the thing. Exceptions aren't about handling errors in your code. They're about handling environmental issues outside of your code.
Like the smog and the pollution.
Right.
Stuff
So
like
saying
that.
he must be using F#. Well, to be fair, pure functional programming does lend itself to fewer errors because of the way it's inherently set up to work.
I knew you were going to. I knew you were going to get that in there. That's pretty funny.
Well, it's true. If a method, is a pure functional method, pure function, meaning all it does is take an input and return output, it's very easy to reason about that. As in, when writing in a functional language, your goal is to write functions that don't affect global state as much as possible. I mean, how many errors are caused because another piece of data was changed between method invocations?
Oh, sure. Okay, so I think it's fair to say we can go ahead and move forward now.
Okay, so this is the case of a very simple try-catch scenario. Now, I guess now we can talk about why I previously said that this syntax of the catch block is not something you want to do. Now, also, for the purposes of everything that I'm going to be demonstrating in the rest of this section, the int.tryParse method does not exist. I just want to point that out. Because, and I'll get to some stuff about that in a second. Okay, so let's say we have an int array. What's the output of this program? Out of bounds. Yes, the array is out of bounds. Okay, so we do indeed get an out of bounds array or exception. But I kind of want to point out something about this code. This is not the kind of code that you would ever want to wrap inside of a try-catch if you have, or well, it's not necessarily true, but you would not want to wrap this kind of code inside of a catch block that catches everything. And here's why. If you are ever in a situation where you are indexing an array out of range, that is a bug in your code. That is a logical flaw in your code. There's no reason why that should ever happen. You should always know ahead of time or check by using the length property before you access something inside of an array or a list or any other collection. If this happens, that means something bad happened, and you want to know about that. If this code was buried deep and deep and deep within a very complicated system, and you had it set up like this where everything was wrapped in a try block followed by a catch block that eats everything, you'll run into a situation where your code no longer works and you don't have any indication as to why it doesn't. And if you imagine a 500,000 line code base, tracking that error down would be very painful or near impossible. So using this kind of catch statement or this catch block, which is called the general catch block, using this is very bad because this will eat exceptions that you did not intend to. Remember, for the sake of argument, this particular example, we are only concerned about the int.parse throwing an exception. Remember, you should not use exception handling in cases where you are not certain that you are capturing a specific error. In this case, we are specifically wanting to catch the error instead of int.parse. But because we have this nasty general catch, we're eating a bug. We're eating a bug, and we're never going to be able to find it again, which is going to cause, a very difficult time in the future. So if I were to run this program again, now that the code is, now that the bug is inside of our try block, you'll notice that we immediately jumped into our in catch. So if our code was written in such a way that this catch block was full of code that was designed in the case of an int.parse method failing, then we would have a problem because now we have two scenarios in which this catch code is being invoked. So I want to introduce the next bit of syntax we can use with the catch block. If you recall, int.parse throws what's called a format exception. What we can do is we can have our catch block only catch exceptions of a particular type. So I want to also point this out really quickly here. Exceptions are objects. Exceptions are objects that are instantiated from one of the variety of exception types available in the .NET framework or in any exception type that you were to write yourself. So because they're types, I can go ahead and say Okay, if the exception that was thrown is a format exception, then execute this catch block. But notice how we no longer have any sort of catch block that's going to catch a index out of bounds exception. So what's the output of the program now?
Nice, Don.
Yep. So we're still getting an exception now. Because our catch block, our single catch block only catches a very specific exception, and we ignore all other exceptions. And the reason is, again, we don't want to catch every exception because exceptions are often caused by bugs. In fact, relatively rarely will you run into an instance where an exception is actually thrown that you do indeed want to handle. And scenarios like that are typically when dealing with external resources or file input or output, or other sort of scenarios like that. So what about an idiot user? That's a good question. Generally, you should prefer, and this is another design consideration about exceptions, always prefer to do input validation as a part of your logic, period, rather than thinking that exceptions are somehow going to provide a good mechanism for validation. Now, sure, we could use exception handling to provide validation for user input, but that's not what they're there for. Exceptions are not there for control flow. And I've seen a lot of instances where people do use exceptions for control flow, and it makes their code very difficult to understand. An exception means I am throwing up my hands, taking my toys, and walking home. It should only happen when something incredibly bad happened. Something out of your program's control happened. And user input, I mean, it pains me to say it, but you are responsible for sanitizing and validating user input, no matter how stupid the user is. So you're always going to want to handle that in your code, in your actual logic, rather than using exceptions to allow your code to flow differently. I mean, did I answer that? I mean, I wasn't trying to say that wasn't a valid question. It is, but I just wanted to make sure that I was, yeah. Okay. So exception handling is, I mean, so far we've seen the general catch block. We've seen a catch block with a specific type. But we can actually do something more interesting than that. What if we did have actual, real, sane, appropriate code that we wanted to execute every time an index out of range exception happened within our try block? But we also wanted to keep our sane, reasonable code for handling the case of a format exception. Well, the try block can support as many catch blocks as you want. Somebody asked, can we not do proper input without try-catch code? Can we? Yes?
I mean, we've gone over the try parse,
Yeah,
but we're
the
pretending that
parse.
yeah, we're pretending that well, I just say try parse in general because it's on int, doubles, etc. But we're pretending that particular thing does not exist. That particular method is not available.
Right. Unfortunately, because the legitimate reasons that I would use for exception handling, I mean, it is knowing about exceptions and how they behave, and the do's and don'ts of exception handling is something very good to learn early on. But there aren't a lot of scenarios that I can foresee, in the homework in particular. Well, in this homework, I can think of one instance, but other than that, where you would actually want to catch exceptions. because, again, if your code does not depend in any way on the external world, there's logically no reason for your code to have exception handling in it whatsoever. If your code does in some way depend on the external world, then if you don't want your program to crash, if something happens, like a file isn't found or a network stream closes, then you'll want to put in
you use that as
stuff.
examples on Monday, which are good ones, because as Ken just said in the questions panel, he goes, I think I'm looking for examples. Some of the things that you were talking about is what happens if you were writing out to a file or tried to write out to a file that just got deleted off the hard drive, or...
Yeah, or someone unplugged your hard drive, or stuff like that.
And you don't want your application to explode. Instead, you want to gracefully handle the situation that just occurred.
Right.
But as Nelson's trying to get across is we're not talking about things that are like syntax error based or things that should truly be reported if it went wrong, such as some sort of out of bounds problem. That would be bad. You'd want your program to crash. You don't want to try to handle situations like that. But if a file doesn't exist and you're wanting to write to it, then you could go ahead and create it. So you could basically catch that problem. Now, there's automated ways of going about that, but that's trying to give a simple example. Because to get into some of the more to really get a true understanding of the use of try-catch, you really need to be involved in some far more complex problems.
Right, but you will be seeing a lot of exceptions, especially when you just start, and they're very important to understand what they are and how to catch them, even if there aren't very many scenarios in which you would. And then definitely once we start talking about the finally block, that's going to be very important.
But Ken said unexpected results. Yeah.
Is this what try-parse does under the hood? No. I highly, 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 highly doubt that. You're actually not the first person to ask that. I kind of want to know the answer to it, but I highly, highly, highly doubt it.
So stand back. Nelson's going to find out the answer.
Yeah, just give it a sec.
Yo, TF.
Well, I could have sworn I asked Visual Studio to open, but you never know. Oh, there we go. Oh, come on. 130.
Oh, you launched this back over. Oh, yeah.
Well, yeah, because with this, I can go ahead and do that. Nope. If you look right here, it says try string to number, which ultimately will return false if it fails during the actual execution of the method. So no. I was 99.9% certain that it didn't in the first place, simply because that would be silly of them. But
they've done silly things before.
Yes, they have. Is this what's used in programs that debugging bug report functions when it crashes? Quite possibly, yeah. It's one solution for it. I mean, if in your main program you do have a general catch like this, where instead of trying to do anything or recover anything, I can actually show that in a second here.
Yes, I was about to say hang tight on that, because the answer is yes. And that's a good example where we still may want the program to actually crash. But before it does, what happens if you want to log that to some sort of error log?
Right, and you would want to do this at the topmost level of your application. You wouldn't want to do this inside of any other particular methods.
So bear with us because we are getting to something like that tonight.
Okay, so is everybody good with general catch blocks, catches with types, and multiple catch blocks associated with a single try? Okay. So actually, I guess I could go into that right now, Jason.
Yeah.
I think so. What do you guys think this does? It's not a general catch block, but we are specifying a type. What do you think will happen when I hit F5? You're brilliant. That would be nice. We get an in catch. The reason is the exception type is going to match every other exception type. The exception type is the base class for all other exception types. In fact, every exception type must be a derivative of the exception type. Now, we haven't talked about classes much or inheritance or those sort of things, but for now, just think about this as basically the exact same thing as this. But it offers us one major advantage. The one major advantage is, if you recall, I said that exceptions were objects. So far, we've in no way been getting those objects. But we can. Oh, what are you complaining about? Oh, that's fine. Okay. So the exception identifier following the exception type is actually going to represent the object. It's going to be a variable that points to the object that was thrown when an exception occurred. So now we have a way to actually gather data about the exception that happened during execution of the program. Now, this is how you would go ahead and implement a submit bug report thingy. You could say, you know, do you want to submit the following bug report? And you could say plus exception.toString. And if I were to run this, it would say, do you want to submit the following bug report? System.invalid out of range, index out of range exception. Index was outside the bounds of the array, including the method that it happened in, as well as the file and the line. Now, the file and the line that it happened in won't always appear. There's some certain situations I'm not going to get into, in which case they will appear. But this is how you would implement a catch-all bug report submission doohickey thing. So is everybody good with the idea of actually capturing the variable that represents our exception and using it to perform not specific code that corrects the situation, but at least sending the information out to a third party before the program finally terminates? I guess nobody's good with that.
And over in the questions panel, anything?
It'll only catch the first exception then. Right, that's a good question. When the index out of range exception happens here on line 15, execution of this try block immediately ceases. Line 17 and line 18 don't happen, meaning there's no physical way for more than one exception to be generated. Are people saying stuff in the chat because maybe I'm broke?
No, it's been quiet.
Huh.
Somebody say something over in BuzzNet.
Talk to me. Wow.
Did it break?
It's really quiet. Did it break? We go ahead and refresh. Or is just everybody playing a practical joke on us? Okay, now somebody typed something into BuzzNet. I just reloaded.
Tell me if you see something new come in.
You'll see what you type, by the way.
Yeah.
Oh, I just saw Wyke.
Okay, yeah, then it's dead for me too. Darn it. Is that signal R failing?
I don't know.
Okay, well, I went ahead and refreshed.
Yeah, now I can see people.
Yeah. Now we can see you.
And remember, if BuzzNet chat did actually break, you will still see what you typed in.
Right.
Even if it was broken, so I'll have to go over the logs.
Okay, so anyways, back to the reason we were looking over there to begin with. Any more questions about this?
Yep, any more questions? Or are you guys good? Lyric, actually, yes, that was an exception caused by BuzzNet. Something that should have never happened.
And Wyke
asked a good question.
Mm-hmm.
The answer is no, exception is not a string. It is an object. Well, a string is an object, but it's a special object with a lot of cool stuff in it. The most important ones are going to be message, stack trace, and inner exception. Now, if you do a .toString, you're going to get a lot of information already presented. You'll get the type of the exception, the message of the exception, and the stack trace of the exception. But you can pull each one of these things apart individually. In addition, if this exception was caused by another exception, the inner exception property will be set on this exception object.
And if that wasn't enough exceptions for you, just hang tight. We're going to get deeper.
So,
Yeah, but if you leave off the toString, won't it? Leave off toString real quick.
Shouldn't. I'd be very. Aww.
What happened?
Aww.
What are you on about?
String concatenation works with exceptions. I don't like that design. It shouldn't.
Yeah, I thought it did.
Well, see, I don't use string concatenation. I haven't used string concatenation since I got ReSharper. Okay. I don't see you elevating. You'll have to refresh, I think. Oh, no, I see you. Never mind. Okay, so so we should encapsulate all our executable code in a try block. No, not unless in a production build that you distribute. It could be an option if inside of your catch block you have code that submits the bug report to yourself. Otherwise, avoid doing that. Because, I mean, look at this. You notice anything wrong about this, anybody? If an exception did actually happen in your code, do you notice anything that could be an issue? Any guesses?
It's a very easy one, guys.
In fact, I'm going to, any problems?
Anyone? Bueller? How about another console write line? Oh, TF, nice.
Suppressing, yep. TF says that we are suppressing the exception, which means, yes, I ate all of the bugs.
Yep.
In fact, of this program, unless console.readkey throws an exception. Yes, we no longer get any indication as we're developing that there has been an error. If I were to instead have removed this exception handling, I could go ahead and hit F5, and you'll see that Visual Studio helpfully tells us exactly where a problem occurred. That won't happen if you wrap your development builds in a giant try-catch block.
So no, you don't ever want to do that.
So you use try for testing? Well, actually, it was the opposite. If you do submit your application to another person and you're curious as to what exceptions happened on in your program from their machine, then wrapping it in a general try catch would be a beneficial thing, because then you could submit an email or something. But especially in development, you should not do that. In development, the only time you should catch an exception.
I mean,
in fact, this is true for.
I mean, if you wanted to do that, I mean, and you're about to talk about rethrowing, I would assume, but you'd want to make sure that after it sent it off to you or wrote it somewhere, you'd want to go ahead and rethrow the exception so you didn't need it, because you don't want to risk the program continuing execution with something being messed up.
Right, and especially once I mean,
that could be very bad, yes.
So let's talk about rethrowing. What am I doing? I was looking away while I was typing. What do you think that does, guys?
I swear we used that on Monday.
I think we did rethrowing, but we never did throwing our own.
No, we did not do throwing our own, but you just said did we do throw, and yes, we did. I thought we did.
Oh, we weren't talking about the same thing, I guess, apparently. Okay, so if I go ahead and do that, we do get a message printed out to the user, and immediately after that, we do get an exception thrown, and the program's execution terminates.
And we get the proper exception as well.
Right. Even though it'd still be kind of a pain to, it's still pointing at the wrong line stuff. For development builds, I still wouldn't recommend doing this.
Right.
For production builds, then I would.
But this way, the most important thing, though, is here we're not eating the exception.
Yep. Alrighty. What if there are multiple exceptions? There generally can't be. There can only be one exception per thread at a time. Because when an exception happens, it stops execution until it finds a catch block that is capable of handling it. You can't have two exceptions bubbling up at a time. Now, if you had multiple threads, potentially every thread could throw an exception at the same time, and there are ways of dealing with that scenario. But in this scenario, there is no possible way that more than one exception can be thrown at a single time.
So, Nelson, you want to go ahead and demonstrate how now we can use multiple catches?
You mean as well? I mean, I did already.
Did you do that?
Yeah.
Oh.
I already had multiple like that and stuff.
Oh, okay. Wow, I missed that totally. Sorry.
Okay.
It's been a long, painful day.
Yeah, TF brings up one of the most famous problems of computer science. A program can never find out if another program has been halted, or not halted, but will continue forever, or become into an infinite loop. That's impossible, which I think is kind of fun to think about. But then again, I'm kind of crazy. Okay, so we've talked about tries and catches, but we can pair up tries to something else, and something fairly cool. I'm going to go ahead and write a completely inane method. Alrighty. What's the output of this method? I have no clue. You just typed on 4 lines at once. Somebody did ask, I imagine this happens very rarely, but what happens if you get an exception in the catch block? Well, the same thing happens. Now, if that catch block was inside of another try block that caught that exception, then execution would just continue as if the exception had been thrown, which it had been. Okay, we got a 3, 10, 5,000, 10,000 cleanup. We got a cleanup 3, cleanup at 100, cleanup at 100, cleanup at 10,000. We got a 3, 5, 5,000, 10,000 cleanup.
Yeah, don't be shy. Get your hands in there and get them dirty. Give a guess.
3, 100, 5,000, 10,000.
Looks like quite a few of you guys are about to learn something new.
We get a cleanup. We get a clean down. All right. Well, you guys ready for this?
Let's do it.
Wait, why is cleanup first? That's a good question. This is called the try finally block. Before I go ahead and close this program, go ahead and just see that it did cleanup 3, cleanup 100, cleanup 100, cleanup 100. Oh, wow. I should have done the bigger ones first. Well, anyway, regardless, the point here was what I was shooting for was this, actually. Okay. So, this is what the output of this program is. And there's a very straightforward reason why this is happening. This is an example of the try finally block. Now, the try block, just like before, it's the keyword try followed by a block of code. The finally block, which is only valid inside the context or immediately after a try block or a catch block, will execute no matter what happens in the try block. So I'm actually going to throw 2 new things at you guys right now. I'll give you guys a hint. This program will crash, but there will be input before the program crashes. Or, well, actually, let's make it not crash because then it won't even get to it. The debugger will just... Okay. So remember how I defined the finally block. No matter what happens, it always runs. So the 2 new things I want to go ahead and introduce is, first of all, this is how you throw an exception yourself. Specifically, the exception. You say throw, and then you instantiate an exception. Just like how you instantiated a list, just how you instantiated arrays, just how you instantiated the random class. You're instantiating the exception class, and you're attaching it to the throw keyword. So if we go ahead and run this, we get cleanup and error. Can you use try, catch, and finally? Yes, and we'll be looking at that in a second here. So you'll notice cleanup still got invoked. Although an exception did happen. Exception happened right here. That exception went all the way back up to line 14, and it immediately terminated the execution of this try block. And then execution went immediately into this catch block. But before that happened, the second execution left this try block that he finally executed. Whether or not the method returned or threw an exception. So the finally block will always execute. We can throw exceptions, we can return, and so on. But why is finally executed first? Well, what are you referring to this? Or there we go. Are you referring to this? How cleanup is before every number? Well, look at this code right here. This is a very imperative concept right here. And I mean that in the sense that it's very, do this, do this, do this. You are commanding a sequence of events to occur. And it's actually backwards to the way you'd think it would be. We are telling console.writeLine to print out my method with an argument of 3, but what happens actually is that my method with a value of 3 as its argument gets invoked first. This method gets invoked before the console.writeLine is even talked to. Once that method is invoked, its return value gets passed into console.writeLine. Because this happens, this method gets invoked. We enter line 31. When we enter line 31, we'll continue down through all these if checks, and we'll hit line 46. 46 will say return 3. Well, this code happens to be inside of a try finally block, and because it happens to be within a try finally block, before it even leaves the method, the finally will execute. For example, I could say, well, I couldn't because it's a return, but what's happening here is that the return is ending the execution of the method, but the finally will always run, whether or not execution of the method was, well, when the execution of the method is ended, or more specifically, when execution leaves this try block, this finally block will always execute. Okay, so because there's no catch in my method, the exception is handled by the main method try block. Yes. In that example, because there was no catch handler here, exceptions will bubble up through what's called the call stack, which is something that we're going to be seeing represented in the debugger here at the end of this class. But it bubbles up through the chain of method invocations that led it there to the first bit of code that is capable of handling that exception. That's why when we do int.parse ASDF, that's why our try block or our catch block is executed, because int.parse ASDF is the person who's throwing the exception. In fact, it's not even, as we saw earlier when I jumped into the source code, there's actually a few methods deep that the exception is even thrown. And then once the exception is thrown, the call stack gets unwound, meaning the runtime says, okay, does this method that invoked this method, does he have a catch block that we can use? No. Okay, so let's go up one more in the call stack. Okay, does this method who invoked that method have a catch block that we can use? No. Let's keep on going and going and going until, in this case, we hit main, where there is a catch block that's capable of handling that exception. So execution then continues on line 22. If there were not a catch block that can handle the exception thrown, or if there was no try or catch block present in this code, that exception would bubble up all the way past main into the actual operating system. Okay, so I also want to go ahead and, so we talked about that a little bit. Somebody asked, can you have a try, catch, and finally? And you can. What do you think the output of this is going to be? We get some stuff errors and some error stuffs. We get some stuffs. Okay. So it looks like the consensus is error stuff, although there were a few stuff errors. The finally block is going to be executed after all of the catch blocks have executed. That's just a convention of how these blocks work. Okay, so we have seen a variety of things. We've seen the try block. We've seen the general catch block. We've seen rethrowing exceptions. We've seen the finally block. We've seen multiple catch blocks. We've seen catch blocks with specific exceptions. And we've seen catch blocks with variables that we can access representing the exception. And finally, we've seen throwing our own exceptions. Yeah, I mean, it's been about an hour, and I think I'm getting ready to move on here. So I guess I can just leave this up and see if anybody has any questions while I'm outside.
Yeah, that's perfect. Let's go ahead and take a 10-minute break, guys, and then we'll resume. So I'm going to go ahead and pause the video here. And we're back.
Okay, where you just did catch exception E, as well as just catch with nothing after it. What happens? Both? Good question, neither, or one. In this case, both of these catches do the exact same thing. This is just a special syntax for doing essentially this without having access to, obviously, you don't have access to the exception object. In this case, this catch will be handled. The first one that can match the exception will be handled, and the rest of them will be ignored. How did you type on multiple lines at the same time? Heretic. That's actually going to be the hold down Alt, click and drag to create a box selection, and start typing. And then, for example, if I wanted to change this all from right line to right, I could hold down block or hold down Alt, block select everything, and hit backspace. So that's a cool little IDE trick. Hi, can you please repeat the catch format exception part? I was having connection troubles during the first half hour of the show. This catch will be handled when a format exception is thrown. See, this catch is going to be executed when any exception is thrown. This one is very specific in that it's only going to catch format exceptions. It's not going to catch index out of range exceptions or invalid operation exceptions or any of the other kinds of exceptions. It's only going to catch format exceptions. Okay. So I guess everybody is good with exception.
I would think so.
If you have a format exception, will the second catch be called to? No. The format exception will supersede this exception block. Alrighty, so what's next?
Well, next thing is, like we did the other day, we could go ahead and introduce them to the String.Format before we get into file I/O. Again,
Okay.
new stuff, but it's very useful.
Yep. Inside of the C# programming language, or in the .NET framework in general, there's this concept of string formatting. So I could create an output string. I could say string output, or I could say, first we can say int string name equals Nelson, int age equals 10 or 124 or something like that. And we could say string output equals my name is name plus, and my age is age. And then we can say console.writeLine output, for example. Is everybody pretty comfortable with what's going on here? Just straightforward string concatenation. Alrighty. So this is obnoxious to write, and I hate it. Especially once you start concatenating maybe 2, 3, or 4 variables at once, things get very, very messy very quickly. .NET has this concept of string formatting, and there are a variety of places where string formatting is accepted. I'm going to show the most basic form first. The most basic form is, not surprisingly, the string.format method. Now, the string.format method is a method that takes in a string format. And a string format is going to be a special string with a special bit of syntax inside of it. And then you're going to follow the string that you pass in with variables that are going to be placed inside of the string at specific locations. So for example, what I could do is say this. So now if I go ahead and hit F5, we get my name is Nelson and my age is 124. Yeah, it's very similar to the printf function inside of C, but a lot better. So what's going on here? We pass in the string format as the first argument. The string format in this case has 2 very simple instructions in the form of what are called placeholders. So we have 2 placeholders here, 0 and 1. These placeholders are going to correspond to the arguments that we pass in immediately following the format string. Now, the order in which we use these is irrelevant. I could use 1 and then I could use 0. For example, my name is 1024, my age is Nelson. Alternatively, I could repeat this over and over and over again and still get the same output. Well, not the same output, but what you would expect. So you can reuse these placeholders in any order. You can choose not to use any particular placeholder if you want to. You can reuse placeholders over and over again. Now, what you cannot do is use a placeholder that doesn't exist. I cannot say my name is 1 and only pass in a single argument. Now remember, everything in C# is going to be 0 index based. That includes the syntax, meaning that the 0th index is going to be the first item. The first index is going to be the second item. Because we're only passing in a single variable, yet we are referring to the second item inside of our format string, guess what we're going to get if I hit F5? We get a format exception. Elevating, I would think it would be an out of range exception, but instead we get a format exception. Personally, I'd rather see an index out of range exception here, but this is just how it works. So whatever. But still, we get an exception. So pretty straightforward stuff. I mean, I would think. We're simply passing in a format string, supplying placeholders, and then providing the arguments that go into those placeholders. So is everybody good with what is on the screen at the moment? Any questions? Alrighty. So like I said earlier, there are a variety of places in the .NET framework and in third-party libraries that take in syntax like this. String.Format isn't the only one. The characteristics of String.Format, however, are that they're going to return the result directly into something you can alias into a variable. However, the console.WriteLine method does actually support string formats inherently. So I could say here, so it's very nice, very straightforward, very clear. So there's a lot of other instances where this is applicable. There are, overloads on file writing. A lot of the logging libraries have overloads for this sort of stuff. So just being familiar with the syntax of format strings is very important because it's used quite often between different parts of the BCL and third-party libraries. How would you print out semis inside the curlies inside the string? Good question. You escape the curlies with two curlies. So if I were to run this now, you'll see my name is curly0 curly and my age is 124. How if you had two strings and one int? Do you mean something like that's a Python thing, with the exception of one certain type of syntax that we're not going to talk about. If you do this, we will get an error because I forgot to change the name over. But if we do this, we will simply get my name is Nelson, my age is 124. We're providing 3 arguments, but we're only accessing the first 2. Okay. Darth Greg, yes. When I did this, it printed out the literal curly0 curly rather than my actual variable that I supplied at the first index. No. I was just asked if I could use something like this. This is not valid. But there's a lot of fun stuff we can do with inside of these curly braces.
I just have to say, but Ty almost made me spit out my coffee. He actually asked a question over in the question panel.
I know, it's surprising.
I was like, whoa, what was... Anyways, continue.
Okay. So if there's any more questions about what I have on the screen right now, otherwise I just want to show a few fun things we can do with format exceptions. Alrighty. I might be bringing up memories with this. Okay. No, that's really not the best way. It's just late. Alrighty, so yes, I know about overwrite. Well, actually, more specifically, you just reminded me about overwrite. Now I feel stupid. Okay, so do people kind of remember this whole thing? There's some fun stuff we can do with string formats that'll actually make the printing of this very straightforward. Oh, great. Maybe that. It's gonna make me cry. Alrighty. Does everybody kind of see what's going on here? What we have done is we've instructed the string format to provide padding for each one of the arguments that we're going to pass in. Very cool stuff. We can even do better than that, though. Let's say close was actually, let's say hang in there was a fractional game where there's actually like 10 digits, and we used floats with decimal points. Let's say we had this. That's done. Okay. Yes, it is a DOS keyboard, by the way. It's the best DOS keyboard, and DOS keyboards are the best keyboards. Okay, so what if we wanted to go ahead and present each one of these numbers, but you notice how they do show their fractional parts, but they don't show any sort of padding. Quite often, especially when it comes to money, we want to actually say that if there are only, for example, one level of precision, we want to pad it with zeros. So how would we go about doing that? You guys see what that did? We've added padding in the form of these digits here. One more IDE question. How are you skipping to the end of the line? I use the end key. So the end key goes to the end of the line. The home key goes to the beginning of the line. If you double tap the home key, you'll end up at the beginning of the file. Okay, so here's something we can do with numbers that's cool. But let's say we had really big numbers. Most often, we really want to have, so in this case, we would want to support having commas in between these numbers in each of the thousands place, or periods if you're French or any other the countries that do that sort of thing. What we can do here is instead of the F, we can go ahead and say N. So by saying N2, we are saying, give us a number formatted like a number and give us 2 levels of precision. Furthermore, the comma right here is determined by what's called the current culture. And the current culture is going to be, in this case, EN-US, because I'm English and I live in the US. But if it were something different, you would get a different result here. The point is, string formatting is culturally aware, which is very, very nice. So somebody asked, what if you did F20, would that break formatting? It would. If I did F20, we would get 20 levels of precision, but you would see that it superseded our padding and caused the entire line to be pushed to the right. Okay, there's other fun stuff we could do. I guess we can do hexadecimal if we wanted to, or not in this case because it's a float, not an integer. If it were an integer, this would result in a hexadecimal representation. We can do currency with the C. We can do percent with, I think it's is it the P? So you see we formatted this as currency, and we formatted this as percent. And you see we sort of broke the formatting right there because of the percent key. Can you do center alignment? Not to my knowledge. So if I took a digit out here, it won't break the formatting anymore. So you can see we can do currency, we can do percentages, we can do padding, we can do numbers. There's some more fun stuff when we start working with dates. And yeah, there's a lot of fun stuff you can do with string formatting. But I just kind of wanted to, the main thing to get away from this is twofold. First of all, padding is very important when dealing with console applications. And the second thing to take away from this is just the general concept of providing placeholders within a single string, followed by the arguments to fill the string up with. Can your padding be variable? I'm not sure what you mean by that. To my knowledge, the only way to get the padding is to provide a piece of text inside of here. Now, if you wanted to go all crazy, you could use this in combination with string concatenation to get the result. I mean, I guess you could do that, but that's going to be very ugly. And also, finally, you notice as I was using -13. If I simply do 13 on these first two arguments, you'll see that it pads to the right. Or sorry, it puts in padding characters to the left rather than to the right. Okay, anyone? Anyone have a question? Doesn't look like it. Okay, well, let's, I guess, move on.
Yeah.
Do people like string formatting?
They better, because we're going to start using it a lot. I'm just saying. Love it. Ken, no? What?
Somebody asked, why do I use the, Don, or elevating, were you referring to like this? Yes, you do have to use it. If I were to say that, it would be an error. Okay, so I guess this example is going away. And we're going to move on.
Okay, sounds good. So the next thing that we had up was another thing that we added in for the class at the last minute, like Monday, which is file I/O.
Okay. So, file I/O, and I/O of any type, really. And when I say I/O, I mean input and output. Input and output of any type is actually kind of a rather convoluted process. The reason it's a convoluted process is you will typically not receive the total amount of information that you need at any given time, especially when you start talking about network streams. But even more local than that, even on your disk, there's a lot of latency involved with disk I/O. And there's a lot of situations where you need to actually encode the concept of retrieving chunks of data at a time into your actual program. Otherwise, you will cause, well, a hang-up in your program, and it won't be very responsive, and it'll consume a bunch of memory. So the .NET framework creators address this problem with the concept of what are called streams. A stream is another kind of object that we can use to retrieve or to write data to another location, regardless of what that location actually is, in blocks. Now, all network I/O, all file I/O, and even some memory I/O, if you wanted to use a memory stream, are handled with the streams, the concept of streams. We're not going to take a huge in-depth look into streams. Instead, what we're going to introduce are two objects that are wrappers around streams for the use of files. So these two objects, StreamReader and StreamWriter, we'll be taking a look at and how to use to interact with a file on your hard drive. The first thing you're going to have to do is add a namespace import at the top of your file. The reason is all of the input-output objects in .NET, or rather types in .NET, are going to be located under the very aptly named system.io namespace. So you're going to have to make sure that you have the system.io namespace imported on the top of your file if you want to access these types that we're about to use. Ryan asked, for storing high scores in a game? Well, sure. For storing anything, really. Anytime you need persistent storage, there's no other mechanism other than writing to a file or to a network stream so that it's saved on another computer. So let's go ahead and look at the StreamWriter class. We're going to look at writing files first. StreamWriter class, again, is a wrapper over basic streams that provides a lot of functionality we are going to be using in order to write effectively to a text file. I want to stress this really quickly here. Do people here know what encoding is?
I would
better note. TF.
I would just, yeah, I would say no.
Okay. Every bit of text on a computer, every bit of human readable text on a computer has to be encoded in some way so that the operating system knows which glyphs to represent for a particular string of text. Otherwise, data is known as binary. So you have two things you can think of. You can have text or binary. Binary is straight, pure data written to something. Just straight, pure data, has no semantics whatsoever to anything outside of the programs that specifically know how to read and write from it. Imagine trying to open up a PSD file from Photoshop in Word, for example. Because a PSD file format is a binary format, Word has no comprehension of how to understand it. It's a binary format. It just has meaning to Photoshop. We're not going to be talking about reading and writing to binary files here. We're going to be talking about reading and writing to text files. Now, there's an important distinction. Text files are encoded, which means at the core, they're still binary files, but they follow a certain contract that is known across all applications and is standardized by ISO. And it's just a common language for describing text between various programs. So when we print out to this file that we're about to print out to, and we can open it up in Notepad, that is not magic. That is because the code that we're going to be using to write to that text file understands the UTF-8 encoding, which is a very common form of encoding. It's going to write data to that text file using that encoding, and Notepad is going to understand how to pull that data out and use it to represent text. So it's not a magical thing. I just want to make the distinction here that the StreamWriter class is not appropriate for writing binary data. Instead, it's appropriate for writing text. Just like how the CS file is just a text file using a particular encoding. In fact, the encoding that this text file is using is UTF-8. It is possible to place a variety of characters in the identifiers of your program or your classes, for example, which kind of gets fun, some of the stuff you can do with it. But I just wanted to make that quick distinction of what we're doing here. We're not writing binary files. We're not going to be writing binary files. We're writing text files. There's nothing magical about text files other than there's an unspoken agreement between the code that we're going to be using to write the file and the programs we're going to be using to open the file. Okay, StreamWriters. StreamWriter is a class. We are going to create a StreamWriter, and we are going to create a StreamWriter variable called StreamWriter, and then we're going to instantiate it to a new StreamWriter. But during instantiation, we need to pass in a few things. We can pass in a base stream if we want, but again, we're not talking about base streams. That's not important right here. Instead, we're going to use an overload that allows us to pass in a path to a file that the StreamWriter is then going to, behind the scenes, open up a stream that it can use to write to this file. You'll also notice a variety of other overloads. For example, we could pass in a stream and, hey, there's that word again, encoding, because the StreamWriter is an encoding-aware class for writing data. Or we can pass in a string path and a Boolean specifying if we should append to the file or completely overwrite the file. The default behavior of the StreamWriter class is to completely overwrite the file that you pass into it. So if we look down here, we have a stream, an encoding, and a buffer size. And if we scroll down here, we have a string path, bool append, and hey, there's another overload that takes an encoding, and then another one that takes an encoding and a buffer size. If you look at the encoding, though, it's going to default to UTF-8. I got this pop-up to appear by entering the open parenthesis character immediately after the type, which followed a new keyword. Alternatively, if this window goes away, you can place your keyboard cursor between the two parentheses and hit Control, Shift, and Space. Not Control Space. TF. Failure. Okay, so let's go ahead and use this overload because we want to pass in a string path that's going to represent a path to a file. Does everybody here know the difference between an absolute and a relative path? TF, I know you do. Okay, so we do have a no in there. So every file on your file system can be referenced by a path to it. For example, if I was to open up this file, and maybe if I go into the properties, it'll show me the location. I'm sure you're familiar with seeing locations like this. C:/ users, Nelson, documents, Visual Studio, blah, 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 blah. This is an example of an absolute path. It's an absolute path because in Windows, it supplies a drive letter. Now, that's not always the case in Unix, so that's going to be Unix, Mac OS, or Linux. You specify the / to indicate an absolute path. In Windows, you specify a drive letter. This is an absolute path because it absolutely identifies a file. There can be no ambiguities between this file represented in this path and any other file. A relative path, for example, if I was to open up my command window and navigate to this path, let's say I wanted to run console application 6.exe. I don't even know what it's going to do. It's going to throw an exception. So you notice how I just had to type in console application 6.exe? That's all I typed in. I could have typed C users, Nelson, documents, Visual Studio 2010, projects, console application 6, bin debug, console application 6.exe. But instead, all I have to do is type in console application 6.exe and hit enter. And of course, that particular build threw an exception, but regardless. This is a relative path, meaning that this path, by default, by not specifying a drive letter, it defaults to the location that we're currently sitting in. There's other fun stuff we can do to absolute path or relative paths. We could say ... which means, okay, take whatever path we're currently sitting in, go up one directory, and then find the console application 6.exe. Well, guess what? There is none, so I get an error. When writing software that uses StreamWriters or file I/O of any type, at least for now, always prefer to use relative pathing. Do not include drive letters. There are situations where production programs will actually use special folders, but we're not going to be worrying about that right now. The biggest reason is simply so that we can actually execute your code on our machines, or, well, more specifically Gav's machine, because absolute paths will cause a dependency that your program must be executing in an environment that has the exact folder structure as the environment you created it in. By using a relative path such as output.txt, this will create an output.txt file in the same directory as our executable. If instead I were to type in this would create an output, well, more than that. This will actually generate an output.txt at the root of my C drive, no matter where my executable is. So I really want to stress that. Okay. So is everybody good now? Any more questions about absolute or relative pathing? Because if you don't understand this concept, then file I/O is going to be very frustrating for you. So if you don't understand, then seriously, just ask a question, because that's what we're here for. The only difference is the C:/, yes. That is the only difference between the two pathing systems. Is that in the DSMV? DSMV? What's a DSMV?
I don't know.
Oh, okay.
It's the TF.
Alrighty. So, can you use system path variables, correct? Yes, if you wanted to. You could also use UNC paths. Okay, so we have some stuff. We instantiated an object. Specifically, we created a variable of type StreamWriter. We gave it the name StreamWriter, and we instantiated it to a new StreamWriter. We told the new StreamWriter that we instantiated that we want to pass, or we want to use the output.txt file. So if I go ahead and type in StreamWriter dot, there's a lot of fun stuff. A lot of fun stuff that we're not actually going to worry about whatsoever. There's two methods that we care about at the moment, write and writeLine. Can anybody guess what these two methods do? Yeah, write text. Writes to the file. Yeah, pretty much. And then also a question came in. The StreamWriter will always create a new file? Yes. There are ways to open up file streams in which an exception will occur if a file doesn't exist, but the StreamWriter is very aggressive. It'll always create a new file for you if it doesn't exist. So if I type in, let's say, writeLine, and I do hello world, we go ahead and run this program. But first, I'm going to go ahead and move that over there and move this over here. And I'm going to go ahead and run this program. First, I'm going to clear all these build artifacts. Any guesses as to what's going to happen when I run this program? All right, no console output, but that's fine. Oh, wait, look, an output.txt appeared. Let's go ahead and open it and see what it shows us. Absolutely nothing. The reason there is a very specific and very important reason why this is blank. Remember how I said streams are not necessarily a simple concept, and the reason they aren't a simple concept is because they abstract the idea of reading and writing in chunks to a resource that may or may not exist or be able to accept what we pass it. The StreamWriter in particular will buffer as much as it can in memory before it actually goes out to perform the write operation. Unless you specifically tell it to, which we are not going to be doing because that's a bad idea, but unless you specifically tell it to, the StreamWriter will continue to buffer the text we pass into it in memory until it decides that it wants to flush. And when I say flush, I mean when it decides it wants to take its internal buffer of the data you want to write and actually send it to the file system. But we can tell it to flush, or we could close it. But we're going to talk about flushing right now. If I do StreamWriter.flush, actually, I'm going to go ahead and do that after the repeat just to make this even more blatant. Go ahead and hit F5. We'll see our output.txt file here. It's empty. Now, if I were to hit a key, though, you'll see Hello World has appeared.
And it went from 0K to 1K.
Yep. So, if we were to, for example, say Hello World, then flush, and then we could keep on doing that, or we can delete these flush operations and write Hello World out 3 times and then do a flush. And now you see we have 3 Hello Worlds in this file. Okay, we still have a problem. Can anybody guess what the problem is? This is the first time this has Yep. Well, yes and no. What we have here is what's called an unmanaged resource. Whenever we instantiate memory inside of C#, that's all managed by the CLR, and we don't have to worry about cleaning up after it. However, when we ask the operating system for anything but memory, for example, a handle to read and write from a file, or more specifically, think about it this way. What happens when we instantiate our StreamWriter is the StreamWriter class goes out to Windows and says, Windows, give me permission to edit this file. And Windows is like, okay, here's a unique identifier that represents your permission to access this file, and it's called a file handle. That file handle is an unmanaged resource. The CLR has no idea that it exists. Now, Windows does. If, for example, when our program exits, Windows is like, oh, they forgot to, close my handle. I'm going to close it for them, whatever. But the StreamWriter still doesn't get notified, so therefore it can't do a flush at that point. So it doesn't stay open past the end of the program, but it does stay open for the duration of the program, which is generally not the behavior that you want. So what we need to do with all unmanaged resources is we need to tell that object that it is no longer used in a very specific and user-defined manner. We have to tell it when we're done with it. And when we tell it that we're done with it, it can then go out and return back the handle that it acquired from Windows and allow the file to be modified by other programs. For example, if I were to go ahead and hit F5 and try to delete this file, look at this. I can't delete this file. The file handle is open. Now again, the file handle does get closed at the end of the program, but this is still bad practice because StreamWriter never gets the opportunity to flush itself. Is there any way to tell what is an unmanaged resource, or do you have to just know? Well, in general, think about it like this. Anything other than memory is going to be an unmanaged resource. All manners of streams, network streams, file streams, those are all unmanaged resources. Anything we have to ask for permission to use that isn't memory is going to be a resource that we're going to have to give back when we're done. Yes, garbage collection is inside the CLR and it works with memory, but it doesn't work with I/O. Okay, so how do we close the stream? Remember in the last example how we can't delete this file? Well, we close the stream by, not surprisingly, invoking the close method on the StreamWriter. The close method does two things. It flushes the buffer in the StreamWriter, and then it closes or gives back the file handle that it previously requested from Windows. Meaning at this point, now that this program is paused here on line 20, I can go ahead and delete this file. See, it's gone now because the program gave the file handle back to Windows. So we were allowed to delete it because there was no more lock on that file. Is there a case where you would want to close but not flush? No, not that I know of. That was a Mr. Bean voice. I don't know if anyone got the reference. Not that I know of, and I don't even know if that's possible to do. Okay, so are the file handles automatically closed once the program fully exits? Yes, but StreamWriter is not told that the file handle got restored, so therefore it has no opportunity to flush its buffer. When would you use a flush instead of closing the file? It's a good question. I generally would not. The use case for me with StreamWriters is quite often I would instantiate a StreamWriter, write a lot of data to it, and close it. If at any, I give the responsibility of determining when to flush the buffer to the StreamWriter class itself. I don't ever find the need to do a flush intermittently myself because the StreamWriter will handle it in cases where I've written sufficient amount of memory into it. Can you open it back up after closing? You cannot open it back up with this class or with this object. You would have to reinstantiate the StreamWriter. But you could reinstantiate the StreamWriter with the same variable if you wanted to. You could say StreamWriter equals new StreamWriter output.txt if you wanted to. But there's no way to reuse the same object to open up a different file or to open up the same file again. Okay, so StreamWriters. Next thing, yes, this also supports formatting, string formatting. As you can see right here, here's an overload that accepts a format string as well as the params object arg. So for example, I could say string name equals Nelson, and I could say hello 0. And if I were to run this, I would get a missing semi error. And then finally, if I ran the output, I would get hello Nelson. Another interesting thing to show would be to append to a file. If I do comma, I can specify a Boolean indicating whether or not I want to append to the file as opposed to recreating it. If I wanted to append to the file, I could simply say true. By saying true, every time I run this program, the file is getting bigger and bigger and bigger and bigger, as you can see. I'm sorry, Nelson, I can't do that. Okay. So, is everybody good so far? Any more questions about writing to files? Or specifically writing UTF-8 encoded text to files?
Yeah. Okay.
All right. You know what I'm going to do?
What's that?
I'm going to do this. I'm going to reset everybody's ready. So how would you go about making this program work without editing lines 13 to 22? You can add code above and, well, you will have to modify code anyway. But the point is if you throw an exception between opening up a StreamWriter and closing it, what code would you use in order to make it so that the StreamWriter always becomes closed, whether or not an exception was thrown or the method was immediately returned out of? How would you guarantee this? I was kind of hoping people to write it out so I can go outside.
All right, well, let's do this. I'll go ahead and hit pause till you get back, but everybody can go ahead and write that out real quick. And we've resumed. I had to resume.
I don't see a whole lot of people ready.
Remember, guys, put those hands down. Hands down. Ha! Click I'm ready.
Okay, so if you're still working, go ahead and hit the 1 minute button. Otherwise, we'll assume that you are AFK. And we are going to assume that you are AFK.
Okay.
Alrighty, so the way that we would write this code in order to guarantee that the stream gets closed. Oh, we have 1 minute. Oh, never mind. The way that we would write this code to guarantee that the stream gets closed no matter what happens during the execution of our program, or specifically the execution of our method. If our method was to return, for example, instead of throwing an exception, our stream wouldn't get closed either. The way that we can guarantee this is pretty straightforward. Okay. So in this case, we are using a try and finally to determine, or not to determine, but to enforce the fact that the StreamWriter will get closed whether or not execution leaves the method that we are currently in. In this way, if we were to either throw a new exception or return, the StreamWriter would get properly closed, and the data would be written to the file, and the file handle would be properly given back to the Windows operating system. Is everybody good with what this code looks like? Alrighty. Yes, there is unreachable code. Because I have this return statement in here, the C# compiler has determined that line 27 will never execute, which is true. There's no circumstance under which this line will execute because of this return statement. Okay, this scenario is so incredibly common when dealing with unmanaged resources of any type that the C# language actually has a built-in syntax in order to deal with it. You guys want to see a magic trick?
Boy.
Okay, this using keyword is in completely different context than the using up here. They are not related whatsoever. In this case, we are specifying a using statement which takes in the parentheses the declaration of the declaration and initialization of an unmanaged resource. What the using statement actually expands into is a try and finally block that will correctly dispose of the unmanaged resource, no matter if an exception is thrown inside of this block or the method is returned out of. It's very, very, very important, very useful syntax that's used for all unmanaged resources. Now, there is a little bit more that's going on behind the scenes with the using statement. Specifically, it's using something called an interface called iDisposable, but we're going to be going over that later. I just wanted to kind of just, throw the word iDisposable out there. StreamWriter is a class that is disposable, meaning it has code written in it that is invoked when the using statement, or in the finally block that the using statement generates for us, and that code is simply going to close out the file. So using as an auto close, pretty much you could say. Basically, the using statement will literally expand into this. Notice how I'm using the dispose method rather than the close method? The dispose method is a special method that the using statement knows about. In this case, the StreamWriter's dispose method simply invokes the close method on it. So, again, if I wanted to refactor this code, I could simply say using Alrighty, any more questions about the using statement? Otherwise, it would be probably time to move on, because it is pretty much using the exact same stuff that we've been learning about this entire class session. If there are any questions about using, now is the time. Someone asked a good question. So if you have the using statement, if you have an exception, will it be handled? The answer is no. It will not catch anything. The using statement does not generate a catch block. It generates a try block and a finally block. Because there is no catch block generated by the using statement, no exceptions are handled by it. However, if an exception is thrown inside the using block, the finally is still executed. Okay.
Yeah.
Sweet. So, can anybody guess what the type is that we use to read text in from a file into our program? Any guesses?
Going once, going twice. Bueller.
Oh, there we
that's
go.
better. We're just checking to see if you guys were still awake. Voodoo hoodoo, you fail.
Okay, we are going to create a stream reader. We're going to instantiate it to a new stream reader, and we are going to use output.txt as the parameter. Now, the stream reader is a little bit more complex than the StreamWriter. Specifically, it's because streams are they're very difficult to reason about, because at a very abstract sense, you never know if a stream has more data in it. You never really know if the other end of the stream closed, died, burned down, got thrown out of an airplane. Any of those things could happen, and the stream would not be in any way notified. So as a result, the code that you write against streams is going to be slightly more difficult to understand than normally. Now, there are some convenience methods on the StreamWriter that we can quickly take a look at. That, however, I discourage their use. We could say console write line stream reader dot read to end. StreamReader.read2end will read every single piece of character, every single character out of the file and turn it into a string and return it. So if I were to run this program, you now see the results of the file. I mean, now that I'm appending stuff, I could actually go into this file and edit it. I can say da-da-da, da-da-da, da-da-da. And then if I run this, we'll actually see that being printed out of the console, because we're telling the stream reader to read to the end of the file and print the result. That's generally not what you would want to do for a variety of reasons. Yeah, I can continue to run this over and over and over again. I'll get more Nelsons in there. But this is generally not. Ooh, somebody asked this question. What happens if the file doesn't exist? So if I go ahead and comment out this code and then delete this file and run it, what we get is going to be an exception. Specifically, the file not found exception. Now, this is an example of where handling exceptions is appropriate. The reason is because this exception here is a result of the environment that our program is running in not having the proper configuration that allows our program to run properly, meaning it doesn't have an output.txt in the folder that we're in. Therefore, the program cannot physically continue to execute, and as a result, it dies in a fire. Now, this would be a case where you would have a try-catch block, where you would say, okay, well, if the file doesn't exist, let's go ahead and create it and try again. That would be a valid use. So if I go ahead and close this and uncomment those out and run this a few times, so now we have our output.txt file again. Okay, a more appropriate way to handle reading from a stream would be to do byte by byte, to be honest, or character by character. That's the most appropriate way to handle it, and that's really the only way you're going to be able to handle large files. But there is a nice little, and the reasoning behind that is that the file might be 12 gigabytes. Even if our program only needs a few megabytes of that data, or our program might not need any of the data of the file at all. It might just immediately send that data out into the console. But the StreamReader.read2end method will take forever to run if it's a 12 gigabyte file. In fact, in a 32-bit process, it will crash. So what do we do instead? Well, the most preferred way is going to be doing something like read block. Read block lets us read in a fixed amount of bytes per iteration and allows us to write really, robust file handling logic that will allow us to handle very, very large files if indeed all we need from those files is a small bit of information. There's a nice compromise, though. That's going to be the read to end method. Or It's going to be the readLine method. The readLine method only applies to text files. There is no corresponding readLine method in a binary file. And the reasoning is what's going to happen is the StreamReader is going to continuously read from the stream until it reaches a character indicating that the line should be terminated. And that character that indicates whether the line should be terminated or not is encoding specific. So here's another example of the implicit language between our code in C# and other programs that might read our files is this encoding, this language that we can communicate with between. And in the UTF-8 encoding, I can't remember what the actual code point is for the new line characters, and there are 2 in Windows, unfortunately. But the point is the StreamReader will continuously read data from the file until it reaches that special magical character. It will return null. Okay, so ANSI is 10 and 13. ANSI is going to be, ASCII. ASCII is actually going to be the same as UTF-8. The UTF-8 encoding was made backwards compatible with ASCII. So almost all of the major ASCII English characters are the same code points as in ASCII. So readLine will return either one of 2 things. It'll return a string representing the line we just read, or it will return null. Another very important concept of this method is that it'll advance the stream for every character that it reads. Meaning, if we were to say console.readLine, if we were to do this, for example, you would get 1, 2, 3, 4, 5, 6, 7, 8 lines worth of data. And we can do better than that. We can put this in a loop, for example. We can say string line equals null, while string line equals console. I'll show you how I would have done this in a second. It's something that might look a little scary to people. Okay, so in this case, we are now reading line by line by line, which is a lot more efficient than doing read to end, meaning we can gradually gather the data we need out of the stream, or even decide to stop reading from the stream at any point, without having to read in the entire file into a single variable. Does everybody understand lines 22 through 31? Alrighty, a fancier way of doing this would be that. If you're new to C#, you don't have to understand that syntax, but I just kind of wanted to throw it out there. That's generally how I would perform this operation. I mean, if anybody has any questions about this syntax, I'd be glad to answer it. We're actually doing a lot better on time than the Monday class. We'll actually be able to talk about enums for a while. All right, so no questions. Okay.
What do you mean everyone seems tired, Ryan? The night class, everyone always seems tired, except us.
Well, it's only 9:30 over here.
It's only 11:30 here. It's early. Coffee plus plus. Yeah, I like that idea. Hang on. Yeah, I heard you drinking yours too, Nelson. All right, and we're ready to go again.
Okay, so we have introduced in this section StreamWriters. We've introduced the concept of flushing. We've introduced the concept of closing. We've introduced using statements. And we've introduced stream readers, we've introduced read to end, and we've introduced read line.
All right, anything over on the questions panel?
Section, yeah, this section's about to be over, so now's your chance.
And anything in the question panel that hasn't been addressed?
Well, there's the for loop instead. I mean, you could use a for loop. I would find that syntax a little bit grosser, though.
Didn't we do something? Didn't we have everybody do a little assignment where, oh, yeah, we did.
Oh, yeah, but I did it for them accidentally.
I thought we had something that looped through asking to, we were putting products in as an example.
Did we do that?
Mm-hmm.
Because that's a homework.
You gave them a basic example, remember?
Well, yeah, I guess I could show that, or have people do it, if they're up to it.
I mean, I thought the example went just a little bit further. I mean, the homework went just a little bit further. Your call. I mean, if everybody's getting this and they're feeling all, you know, awesomeness.
Well, now and people seem to have gotten it. I don't.
Well, let's find out when we have homework.
Alrighty. So I'm about to delete everything in this console window. And we're going to move on to enumerations. We're closing that. We're maximizing that. We're deleting everything in here. Wait. Was that a joke? See, yeah, I thought it was.
Scared the crap out of Nelson.
Okay, so enumerations. Enumerations are a kind of type. No, we're going to be talking about debugging after this, after enumerations. Okay, so enumerations are a kind of type. We've talked about how there are types in the .NET language, .NET framework, and how the types allow us to perform various kinds of functionality. However, one of the most important aspects of types are going to be the fact that they can be used as variables. For example, the integer type, or the system.in32 type, allows us to store numbers. Float type allows us to put decimals in things. The string type allows us to put text in things. The bool type allows us to use one or two values, true or false. Now, the number type, the decimal type, and the text type are all relatively complicated types to what we're actually going to be building here. But we're actually going to be showing you how to build your first user-defined type. And the user-defined type is going to behave very similarly to Booleans. Now, the reason I say that is that Booleans have no concept of arithmetic. They have really no concept of text or of anything else. They're just variables that can contain one of two values. Now, we can actually create a type that allows us to create a variable of that type that can only be a certain range of values that we just define ahead of time. So let's go ahead and create our first type. Now, I kind of did lie in that sense. We have been creating the class type, but I mean, I doubt anybody actually typed that out. So, you know, here's the first real awesome enumeration, or the real awesome type that we can actually use in our program to create really nice, reusable, and you know, readable code. And that's going to be the enum type, short for enumeration. not to be confused with IEnumerable or IEnumerator, which are completely 100% different. So the enum type is defined like this. You start with the keyword enum, then you give it a name. I'm going to give it the name of status. Now, the naming convention of any type you create, regardless of the kind of type, is always going to be uppercase followed by camel case, or what's this called again? Pascal case? Jason?
Do what now?
I forgot the actual term for the uppercase first character.
You don't know the difference between Pascal casing and camel casing? Nelson!
I just don't know the terms. You're the one who introduced me to the terms.
I'm speechless. No, I'm speechless. Give me a minute.
Just because I don't know the.
I'll get it over.
Okay, it's Pascal. It's Pascal case.
Nobody help him. What is wrong with you guys?
I forgot the terminology.
Do you know how to spell your name?
Sometimes.
Nelson.
You're really freaking.
That's it. I'm going to bed.
Okay.
I mean, soon you might ask, what does hello world mean? I mean, or even, how do you make it say hello world? Or I don't know. You might soon ask how to save the file. Yeah, you're absolutely right. Ahare 70. I'm crushed.
I'll be honest. I never used any of those because.
Are you going to just sit here and continue crushing me? What is this all about? We've been getting along good all week.
No, I've never taught to beginners before, so I've never bothered to learn the terms for the different forms of casing. I know what they are, and I know when they're appropriate. There's a difference.
Okay. That's good.
Okay. So, we have a type here. We're creating a type. And the identifier of this type is defined as the name of the type that we can use in our program. And again, it follows the same naming conventions as other kinds of types that we might create, which is Pascal case. Following the keyword in the identifier, we will, not surprisingly, open up some curlies. But what actually goes into these curlies is a little bit different than what you've seen before. What goes into these curlies is a comma-separated list of identifiers. So we could say, I don't know, running, paused, file not found. That's actually a daily WTF joke, if anybody got it.
You're not recovering from that. Continue. Sorry.
Anyway, you what?
None. Continue.
Okay. So now we have a type called status, and we can use it to create variables. Now remember how I've been trying to stress the fact that types, when used in variables, it's really about the kinds of data that they can store. In this case, this type, if we were to create a variable of this type, can store one of three values, and those values are named: running, paused, and file not found. So to create a variable of this type, we start with, well, I didn't mean to do a block select. We start with the type, again, just because it's a variable definition, followed by an identifier, followed by optionally an initializer, but we're not going to be worried about that just yet. So if you are completely new to C#, this is the first real type that you've created, and this is gives you the ability to create variables of this type to do whatever you need to do at this case. So the purpose of enumerations are generally to record the status or the state or any sort of situation where something might be in different states. I mean, that's really what they're good for, mainly. When you're not talking about things like Win32 interop or other sort of things where you basically are using enumerations as a replacement for constants, at a very conceptual level, the concept of enumeration is simply to record that something is in a particular state. So we can do two things with this variable. We can assign it to a state by saying status equals status dot, and then give it one of the states that we defined, such as paused. The second thing we can do is we can compare the state to any of the other any of the other identifiers that we specified up there on lines 11 through 13. In this case, I'm going to use a switch statement to say switch on status. And I'm going to give it different case blocks for the different statuses that are possible, such as case status dot paused. I'm just going to say console write line paused. Case status dot file not found. In case status running. We could also have compared this variable to the other identifiers within the enumeration using the if statement. So for example, I could say if status equals status.paused, then write stuff and things. If I were to hit F5 now, we'll see some relatively straightforward output. Because on line 20, we, again, actually more specifically, or earlier in the program, or not early in the program during compilation, it's not runtime code, lines 9 through 14, we define a type called status, and we give it 3 possible values that any variable of that type can contain. On line 20, we declare a variable named status of type status. On line 21, we set the value of status to status.paused. On line 23, we compare the status to status.paused, and if that's true, if status equals status.paused, then we write out stuff and things. On line 28, we enter a switch statement, which we compare status with the 3 possible values it could be, and we write a different message depending on what those values are. So, how's everybody feeling about enums?
Yeah, maybe. Asleep? Hey, we got a few people awake. Awesome.
So it's an extended Boolean. Certainly, you can think of it like that. More specifically, the WTF case was actually true, false, file not found. There was someone wrote an enumeration with these 3 values. Didn't make any sense. Great website, though. You shouldn't use them as a replacement for Booleans, except in cases where you need to record additional state. Or not additional state, but additional possible states. So as far as enumeration goes, that's really their main use case, is to record what state the program is currently in, or what part of the program is currently in. It's also used as a flag into methods, for example. You might have a method that can perform different operations depending on the enumeration you passed in. Okay, well, that's actually a big question. Wyke asks, do numerics match up, like true is 1? Well, actually, are you talking about the keyword true? The keyword true, the actual literal blue true, has absolutely no built-in or implicit conversion to numbers whatsoever. As it shouldn't. In a lot of languages, it does. A lot of languages, true means 1. Not in C#. There's no implicit conversion between true and a number. And I'm thankful of that, because conceptually, true and falsehood have nothing to do with numbers. Numbers are their own domain. True and false are different. When it comes to enums, though, this is an unfortunate thing about C#, something I don't like very much about the language. In fact, I don't really like the enum. I use the enum construct all the time, but compared to, for example, Java, the Java enumerations are awesome, and the enumeration equivalent in F#, what are they called? Discriminated unions are just, they'll blow your mind. But in C#, they're very simple. And not only are they simple, I believe that they violate a very basic concept. These do have correlations to numbers. In fact, we can override the default correlation to numbers in each one of these. True by default will be 0. False will be 1. File not found will be 2. I could override it. I could say true equals 2. In this case, true will be equivalent to 2. False will be 3, and file not found will be 4. That being said, I think that treating enumeration values as numbers, with the exception of dealing with other libraries, such as 132, is not what enums are about. And I don't believe that that's necessarily that much of an appropriate use of them. People will often have things like true equals, like maybe they'll use enumerations to represent a menu in their user interface, and then they'll have, have the user type in a number between 1 and 10, and then map that number to an enum. It just, that conceptually hurts my brain. I mean, not conceptually, but philosophically. I think that's a misuse of the construct and actually dilutes what enums mean as a construct. Because enumerations are limited, why use enumerations and not another class? Classes do not contain the same kind of things that enums do. Classes contain members such as methods, properties, events, or fields. They don't actually contain the sort of stuff that enums do. Enums instead just represent a single value, and that single value is constrained to anything that you specify inside the type definition. So it's not that enums are limited, it's that they serve an entirely different purpose. So you would say a user should never enter enum directly, but be analyzed by the program. Yes, I would approach the problem like that. It would be more code, but I feel that it would be significantly more correct and less brittle. Because at that point, you do realize that the behavior of your program could be altered simply by changing the order in which your enumeration members appear in. I feel that that's just not only a philosophical violation, but also could introduce very difficult to find bugs within your software. So enum would be controlled defined states for your program. That's a very appropriate use of them, of your program, or maybe of individual components within your program. That's quite often where they're used. I'm not going to talk about it. We do need to do an F# course one of these days, Jason.
I know, and we will.
I just want to talk about discriminated unions for the next 2 hours because those things are fun.
Focus, Nelson. I'm just saying.
Well, I'm waiting on...
Waiting on what?
Waiting on questions. I mean, what else am I...
Well, I mean, we have been going for a while. It's not like it's...
Ooh.
What?
Can you use an enum as a return type? And the answer is yes.
That's actually a very good question. That was not asked in Monday's class.
This is completely valid code, although slightly inane.
It's just funny. You're getting tired.
Alrighty, so if there aren't any more questions, I guess we can move on to debugging.
Nelson, we've done 2.5 hours of recorded, so don't think that this has been a short class.
It just feels short for some reason. I don't know. It feels like. Well, no. How long?
Well, the monster class was.
How long was the Monday class?
3 hours, or just shy of 3 hours.
Huh.
Because you still got to go over debugging, and then once basic debugging's out of the way, we still got to talk about homework.
All right, so that's all there is to enums. There are some more things about enums. For example, we could write out an enum to the screen.
Oh,
if we wanted
just
to.
wanted to point out that the to Lyric real quick that the times I was just spouting out are times based off of actual recorded. That don't. I'm not looking at times of when we started and when we stopped. So I'm just right now we're at 2 hours 27 minutes of actual recorded.
But yeah, as far as enums, what there is to them, you can do things like return a list of names for the enums and stuff like that, or parse. But again, I just don't. I mean, I've explained my reasons for being against using enums for user input and for numerical representation, with, of course, the exception of interrupting with other libraries.
Yeah, Lyric, I think I get what you're saying. Yeah, Mondays classes during the business day are tough. Because when we go on break, it's not really so much a break as it is trying to put out fires and deal with other things. So actually, you're probably right. I'm sure of it.
TF, I don't hate days of the week. That enumeration has its place. I use it often, actually. But just not to present anything to the user. There's a difference. Okay.
You got a request to run that again?
Oh.
Okay.
Pretty. Can you add to the enumeration on the fly to have more states? No. Mandy asks, she's seen stuff like this, which actually is redundant in that case. An enumeration actually does use a number behind the scenes to represent the state that it's in. And you can change what type of the number it uses. So I could say instead, okay, I want to use a long, or I want to use a short, or I want to use a byte, or I want to use something else. So, and not a float, sorry, that's not going to work in that case. But as far as the integral data types, such as byte, char, float, or byte, char, short, int, uint, long, ulong, and so on, you can change the backing type of the enumeration, which should only be used in cases where you are trying to either squeeze a bunch of memory or a bunch of data in a little bit of memory, or you have an enumeration that has values bigger than what an int can store. And if you have an enumeration that big, that's ridiculous. So if you use char, it would be something like, never mind. Char is an integral type. Sorry, tired. It actually lists all the integral types right there. Byte, s, byte, short, u short, int, uint, long, ulong. Okay, so moving on to debugging, I guess. All right. So everybody up until this point, I'm sure, has seen stuff like this. If you were to run this program, what happens is an exception happens, but it's actually a little bit more interesting than just an exception happening. What we're looking at is the debugger. The debugger is a program that runs side by side with your program and monitors everything that it does. And if your program would be about to crash because an exception was thrown, it's going to go ahead and do what's called breaking out of your program. It breaks the execution of your program. It pauses your program. And then it's going to, in the case of having Visual Studio open, it's going to go ahead and give you a very nice IDE experience of debugging your program. Very nice visual representation of what exactly is going on. So in this case, we get a nice little, message exception. We get the type, we get the message, and so on. And so we get a lot of cool features already. And we can see exactly the line that our program crashed on. So let's talk about something like this. Let's talk about Okay, the first thing I'm going to show you is the most common use of a debugging session when your program crashes for some reason and throws an unhandled exception. When this happens, what you will generally want to do is inspect something called the call stack. And now I know I talked about call stack briefly earlier, but what the call stack is it's a hierarchy of all the methods that have been invoked up until this point. The reason why it's so important is because you'll generally have relatively small methods that do very specific tasks, and oftentimes the actual method that caused the exception isn't the culprit. It's usually how the method's being used by somebody else, and you really want to get that full picture. So to do that, the first bit of the debugger that I want to show is the call stack window. This is one of the most important windows. I do want to point out that any of the windows that I show here, if you do not see them, make sure you are in debug mode and your application is broken. Go to Debug, Windows, and then open up one of the windows that you see me use. This option only shows when the debugger is currently active. So the call stack allows us to actually, if I double click on each one of these lines here, I can jump back and look at the actual execution that led me into this method that caused the error. So it gives me a lot of interesting context. Furthermore, if, for example, I was to say in method 2, int.myInt equals int.parse console read line, and if I were to run this and type in 423 and hit enter, we'll have some interesting stuff in our call stack. If I was to jump into this method right here, method 2, the method that invoked method 3, I can actually introspect every single value of every single variable with the debugger. I can do that by either mousing over the identifier for the variable in any place that it appears, or looking at my locals, if it's indeed a local variable, or it should be showing up in my autos. I don't have autos in Express, apparently. So if you have Ultimate or whatever, you'll also have another window called Autos, which it should show up in. Now, quick note, I'm not going to be talking about watches or the immediate window or the other windows that you might have in your professional install if you have that. But
we did a full
definitely
debugging course.
Yeah.
A one-night debugging course. Go ahead.
Which is posted?
Yeah.
Okay.
It's actually available.
So,
it's actually available, if I recall, for member sponsors to physically download. Just it's in the member
Cool.
sponsor lounge area.
Alrighty, so you have to click on the methods inside the call stack. Well, you click on the methods inside the call stack to navigate the hierarchy of method invocations that led you to where your program crashed. So you can see right here that we started on main. We went into method 1, into method 2, and then into method 3. And you'll notice that every time I double-click on something in the call stack, this green arrow appears. And this green arrow appears wherever the method was invoked. Okay, so I did talk briefly about introspecting variables. So let's throw up a few more variables. You see my names are getting more creative. Let's talk about introspecting variables, and let's take a quick moment and talk about breakpoints. Now, quite often, you will want to watch your program execute step by step in order to figure out the flow of execution that led your program into a state that caused an issue. So what I mean by that is you want to define a predefined location in your program that the debugger is going to go ahead and halt your program so that you can look at the rest of your program paused and slowly and incrementally walk through the execution of it. You do that by setting breakpoints. And setting a breakpoint is fairly simple. All you have to do is click on the gutter all the way on the left or hit the F9 key. The F9 key will toggle breakpoints. Now when I hit F5, what's going to happen is execution is going to start. It's going to get to the first breakpoint, and then the debugger is going to break out of the execution and show us a nice graphical, not graphical, but semi-graphical with text with colors, and you know what I mean, representation of our running program. So we can do cool stuff like introspect our variables and so on. What we can also do, and this is another very, very important feature of debugging, is step into, step out of, and step over. Those are those buttons up here. We have step into, step over, and step out of. We're going to be talking here about the step into and step over because you will be using these most frequently. The step into method, button, which has the shortcut key of F11, which remember this shortcut key. F11 is a very, very important shortcut key. We'll step into, if I knew which key was F11 on my keyboard, we'll step into the methods as they are executed. So you see, we started in main on line 16, and then we stepped into the invocation of method 1, which brought our execution to line 21. Actually, do want to point out, I want to go ahead and put up a very simple example and explain the yellow. Yellow line is very, very important to understand. Okay, let's go ahead and set a breakpoint on line 16. I'm going to run this program. I'm going to go ahead and move it over here and move the running program over here so we can watch the execution of the program as we step through our execution. So if I go ahead and hit F11, you notice I did hit F11, but I didn't step into the implementation of console.writeLine. By default, the debugger will not step into code that you did not write, or more specifically, it will not step into the code that it does not have the source code for, or the debugging symbols for. So that's very important. So F11 will not jump into predefined methods that are part of the BCL. So I did hit F11, and you notice the 1 appeared. What's going on is this yellow line indicates the next line that's going to be executed when I hit the F11 or F10 key. So now if I were to hit F11 again, you'll notice that 2 gets written out to the console. And if I keep on hitting F11 or F10, we will continue to write out to the console. Now I can continue by hitting F11. That's because we're stepping into the method 1. Then we can step into the method 2. And then watch this. If I hit F10 or F11 on method 2, the debugger actually the program's no longer halted. The program's actually running. The reason it's running is because the console.write readline method is actually going to be waiting for us to type in something before the program runs again. As a result, our debugger considers that a program is still running, just as it did before. If I go ahead and type in a number, however, and hit enter, execution immediately halts again on the beginning of line 37. In which case, I can hit F11 again, and again, and now you'll see we finally get the exception. So we found the bug in our program. We can stop debugging by either hitting this square stop button or by hitting Shift F5. Can you step backwards in the debugger? You actually can. It's very scary, to be honest, but you can. I'm not 100% sure if this works in Express, so it's not my fault if this doesn't work. Ooh, it does work. So what I'm doing is I'm dragging this arrow up to the top of my main method, and I'm continuously executing this code over and over again. So if I look at my console, you'll see that it continuously has printed out all these numbers over and over again. Because I've put it up, and then I hit F5. F5 is another very important keyword, or keyboard shortcut. F5 will continue execution up until the point, this isn't hoisting, TF. F5 will continue execution up to the point where a breakpoint is hit or an exception is thrown. So just as easily I could have hit F10, 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 and then drug this back up, and so on and so on. I'll be honest, I have never used this feature. Ever. I think it's kind of silly.
It's like, no, that wasn't wrong. Drag it back up and try it again.
I mean, well, you know you can. Does this have edit continue support? Oh, it does have edit continue support. So I'm actually changing. I've never used edit and continue either because of some of the restrictions of the bitness of your program. But yeah, there you go. I just edited my program as I was debugging. The reason I don't trust that, I've known about the edit and continue functionality for a very long time, and I played around with it a little bit. I just don't trust it because let's say I'm debugging a method that's invoked 100 times in my application, and then I change it, and I notice I fix a bug. Well, I've just changed the implementation of a method that was previously run 900 times to get to the point that I was. The next time I rerun the application, it's going to be using that new version of the method, which could potentially cause an undefined amount of bugs. So I've never used edit and continue support. Ever. Just because I don't think that's something I could rely on. Not because I don't know what it is or what it does. Yes, I know what its name is. Okay. There are actually better ways to do some of the stuff that you might think that you might want to do inside of the edit continue, and that's with the immediate window. But we're not going to be talking about the immediate window. The immediate window is a window that I use quite often. Okay. So I think that's about it for debugging, unless there's any more questions.
That's the basics. Yeah, any questions and then homework.
Someone's excited for homework.
Yeah, I see. That's awesome. Nice try, Tia. That's cool, Ryan.
I do wish I made the method length requirement smaller, though. I should have made it 20 lines. I mean, realistically, no individual operation you do, perhaps with the exception of user interface, which still could be better done with separate methods, should be more than 20 lines. I'm so glad I haven't introduced fields yet. Fields are abused so much.
Well, let's go ahead and discuss homework.
Alrighty. So, homework. Okay. So the homework is to, well, I guess I'm just going to read this, to write a basic product inventory system that will allow the user to enter product names and product prices. Now, I do want to note here that you must allow for cents. The type of the currency is invalid, but you must allow for cents. And save that data to a file called blah, 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 your 3dbuzz username underscore inventory.txt. Definitely remember to remove special characters from your username. The program, okay, so the execution of the program is going to be, program will load the data. If the file exists, remember to do exception handling here when it starts. Program will allow the user to enter new products, remove existing products, and display the current products. The program will use enumerations to track state and should use different methods correctly to keep individual method line count down. No individual method should be larger than 50 lines of code. Are there any questions about the prompt? Is anybody still alive?
Is anyone breathing? All right. Well, I think that's going to pretty much wrap it up. It's only about 12:15. It was a good night. It's been an awesome Thursday. Lots of stuff. I got lots of encoding to do now.
Brandon asked a good question. Why do we have to track the state? Well, the program could be in a variety of states. It could be displaying to the user the inventory. It could be adding a product or removing a product. Also, there's another question came in BuzzNet. You want removed objects deleted or just marked as removed? Deleted. And remember, when the program exits, it saves back to the file, either when it exits or when you physically make a change to the program. So yeah.
Awesomeness. Well, that's going to wrap things up for tonight's class. Thanks a lot, everyone, for joining us. Wait.
Oh, someone's typing in the question.
Oh, okay.
We never really talked about how to read individual data in Monday's class. Do we write each piece of data in its own line so we can use readline to get it back? That's up to you. Writing each piece of data on separate lines will be significantly easier to parse for your program. Later, once you learn more about like string formatting and string parsing, getting the data on the same line would be very feasible. But keep in mind, if you do try to get both the product name and the product price on the same line and separate them with like commas, for example, think about what your program would do if you put a comma in the name of the product itself. So there's a lot more considerations you have to take into account when storing multiple pieces of data on the same line. So storing it in individual lines would be a lot more straightforward. But the data format is completely up to you as long as it works. Did that answer your question? All right, sweet.
Okay. Well, you guys are very welcome for the class, as I saw some thank yous over there. And we will see you guys. Well, I do want to mention this real quick. It looks like open office hours for this week are just going to end up not happening. We've just run out of time. We do have a class going on tomorrow, a private class, and then there is a Blender class on Saturday. And let me think. And Sunday, I need one day for family. So yeah. So next week we will be back to a regular routine once again. But please feel free to PM us if you have any problems. Yeah, works for me. Work for you, Nelson? Sweet. That's right, Dave. C++ sign up starting tomorrow. So outstanding. Well, you guys have an awesome evening, and if I don't see any of you guys until next week, you guys have a fantastic weekend as well. Goodbye, everyone.
Goodbye.